Good evening, everyone. Thank you so much for coming tonight. My name is Hannah. I'm a post-secondary recruiter here at SAIT. Before we get started, I'd just like to acknowledge that SAIT is located on the traditional territories of the Niitsitapi, Blackfoot, and the people of Treaty 7, which includes the Siksika, the Buganai, the Kainai, the Tsuut'ina, and the Erie Nakota of Bearspaw, Chiniki, and Goodstoney. We are situated in the area the Blackfoot tribes traditionally called Mohkinstsis, where the Bow River meets the Elbow River. We now call it the city of Calgary, which is also home to the Métis Nation Region 3. Tonight we have a hybrid session going on, so we have some people here in person, some people online. We'll be taking questions from everyone. I'd like to now pass it on to our academic chair of Mechanical Engineering Technology Programs, Olga Molokova.
Good evening, everyone. So, shall I look at the camera for online people?
They can see you, but not your eyes.
Okay, so thank you so much for coming. This is really impressive. This is cold, and you're here. That's means a lot. So again, I'm going to present Mechanical Engineering Technology program today, and how to cursor. Where is it? Next slide. How to do it? How did you do it? Okay, I see. Okay, so my name is Olga Molokova. My background is in electromechanical engineering, and I also completed my executive business administration from Haskell School of Business. And I've been here in this role at SAIT for the last 12 years. So mechanical engineering technology is a 2-year technology program. I'd like to comment that we don't have 3-year program anymore, evening. So we put it on hold due to low enrollments. But 2-year program is available, and it's a fully accredited program, technology program. So we are accepting students in the fall, and we are admitting 5 groups of students. So it's about 160 students. And also we have the second intake in January, and we are admitting 2 groups of students. So totally we have 7 groups of first-year students, and then they progress into the second year. So program has 3 majors. And students don't have to think about what major they would like to declare, because the first year is common to all students. No matter what major you prefer, you have to complete all common courses. And we do have specific courses that actually supposed to help students to select their major. For instance, if you look at this map 05, this is a very special course. It's Introduction to Electromechanical, and we introduce students into like electrical circuits, electronic components, PLC programming. And if students like it, most likely they will be joining automation major, and I will explain in more detail later. So Math 200 is a mechanical side of mechanical engineering. I'd like to say that mechanical engineering field is huge, huge. So a lot of sectors of industry actually require technologists in mechanical engineering. So we can think about, let's say, furniture companies. We can think about HVAC companies, manufacturing facilities, oil and gas. They all require mechanical engineering technologists, as well as engineers, of course. So thermodynamics 200, identifying analytical, how good students are with math and analytics. So 3 courses that will guide students which major they want to join. So that's the structure. First semester, second semester. White courses, common courses to all students. And again, here we are going to have 160 students in the fall, and they will start in September, 2 semesters. Then they have a break, summer break, spring, summer, and then they will join the second year. If students admitted in January, it's a fast track program. They will not get any breaks. They will start this first semester in January. They continue the second semester in spring, summer, no break. And then they will join the second year together with those 160 students from the fall. They're combining them together. And for the second year, it's either 6 groups or 7 groups, second year students. And they will be split by majors already. So common courses, well, I think it's logical to accept math, statistics, static statistics, dynamics, all those foundational courses in engineering. That prepares students for their engineering background, right? So I don't want to talk too much about courses one by one, but if you have any questions, yes, you can ask. Any questions so far? Okay. So in the second semester, for the fall semester students, for the fall intake students, or in the first semester for the January intake students, sometime in March, April, we are doing major selection meetings where we discuss what it means, and students have to declare their major. It's in the end of March, beginning of April. So we submit those numbers to the registrar office, and they will be forming groups for the fall. But before that, students have flexibility and they have to ask questions, and they can change their mind. But once it's declared in April, beginning of April, so in order to change the major, they will have to pay a fee. Okay. So that's the first year. That's what it looks like. So then students join the second year. Two groups, design and development, blue line. Two groups. One group is 32 students. We have small classes. 32 students for lecture and 16 students for labs. So two groups, two groups, two groups. Total 6 groups. I'd like you to understand the difference. Just a very brief introduction to what the difference between majors. So blue line is more like visual design or product development. For instance, if you look at the car, let's just use the car because everyone likes cars. So if you look at the body of the car and the chairs inside of the car, that will be developed. Why? Because it's a product. It has to be ergonomically pleasant, so it has to be right shapes, comfortable. They have to look good and be appealing to the customers. They have to have appropriate colors. So this is development. It's very visual. Of course, there is a mechanical engineering component into this, but still, visual is really important. Product development. Very practical, less math courses in that major. Again, just a reminder, white courses are common to all. Blue courses will be very specific, only to design and development. Purple line is traditional mechanical engineering. All traditional engineering courses, math courses, thermodynamics, heat transfer, fluid mechanics, machine dynamics, which is vibration analysis. This one is based on thermodynamics. This one is HVAC course. That was, by the way, requested by construction industry to put it on curriculum, and engineered air hiring our graduates every year because of this course. Okay, so this is very analytical, a lot of math. Those who don't like math, they go to the blue line. Okay, so it's kind of visual, very inventive and creative students who don't like math. They can still work in industry, in furniture companies. Now let's say rapid prototyping shops, some artistic shops, molding companies, all that include more like prototyping. That will be blue line. Analysis will be everywhere. You just name it, everywhere. Manufacturing facilities, oil and gas companies, engineering drawings. They work with engineers to create drawings everywhere. This is analysis. And by the way, and we'll come back to this transfer option discussion. So if you're planning to university, the purple line will prepare you better, although all majors equally accredited and signed for those options. But it just gives you the better foundation in engineering. The green line is automation. Very specific major, very hands-on, a lot of programming. one is in how to integrate systems into production lines, how to align many pieces of equipment into production line. So here, sequence of production events, like let's say we need to create some product, and the product is going through the production line, it's fully automated, and students, well, in their project, they have to identify sequence of events and do programming. Let's say it goes to drilling operation first, then it's going to like measuring, quality control, then it goes to assembly, then it goes to welding, then quality control, and then you have to check everything and put it back to the retrievable storage. Do you understand the big picture? So it's fully automated. Automation is helping to eliminate manual processes with fully automated processes. Okay, so all those 5 courses, they all come. Any questions about majors? Any questions about courses or structure, MET structure, program structure? Okay. So I'm not going to talk about evening program because we just put it on hold for now. During COVID and after COVID, we're not recovering for some reasons. Okay, so we have some students clubs, very few, but very interesting. Again, we're recovering from after COVID. We have Mechanical Engineering Students Association. It's, students have a lot of activities and they're meeting with industries. We are waiting for good leaders to come back to Concrete Toboggan because we don't have Concrete Toboggan team this year. But we cannot push students. It's up to students if they want to participate in those clubs. But a lot of opportunities for students to apply leadership skills and work on those exciting projects. This one is also student club, but it's skills. Do you know what skills is? Skills competition. So we actually achieved our group from automation major. They participate in skills in mechatronics section. Mechatronics is a automation. It's a European word. And they achieved very high results. Last October, students actually traveled to Stuttgart to participate in a world competition in skills. So I don't want to stop here too long, but it's just amazing results students achieved. Okay, so it's very exciting to be at SAIT, honestly. That's what I'm trying to say. It's very exciting to be in our school and in our programs. A lot of activities, very student-oriented programs, and SAIT is very student-oriented. So now about admission requirements for mechanical engineering. So we do require at least 60% in English, 30-1 or 30-2, equally, no difference. In math, if it's 30-1, it's 60%. If it's 30-2, it's going to it needs 75%. Okay. And here it's a little bit complicated. So we either require science 30 or physics plus chemistry 20. A lot of questions about what if I'm getting higher mark in physics or chemistry 30. Admission will pick up the best mark. Whatever you're better with, they will pick up that one and use it for admission. Yes, science story, yeah. We have to get science jump. My preference, my students actually complete all physics and chemistry. And it's more focused on what they need for foundation. But science theory is also good. It's just a little bit over what they need. Okay. Any questions about that? Because usually people, any questions from online people? Nothing yet? Okay. Guys, don't be shy to ask questions. All right.
Question.
Yep.
20 in the chemistry firm, is there a certain grade level?
At least 60. 60.
Oh,
60 for all,
got it.
except math 30-2. If it's math 30-2, we require 75 because it's a little bit not to the same standards. Okay, I think we already discussed majors. This is kind of what analysis do. They focus on energy, HVAC systems, oil and gas, heat equipment, all that stuff. So, and as we discussed, it's all engineering courses. So for design and development, it's again, product development, and focus is on ergonomics, human interaction. It's really important in this case because you need to attract customers, and universal technical design. It still requires your knowledge in strength of material and fluid power and all those things because it's complex design. Like if you look at this chair, you still have those wheels and you have to select the right material. You have to calculate strength, how to design them in order to ensure that it's reliable, right, and functional. And of course, automation. You already heard the word mechatronics. So it's a mixture of few disciplines. Mechanical design is really important as a foundation because it's all robotic systems, all those stations we are using, it all mechanical systems. So also you need to have knowledge in programming, PLC programming and general programming. We call it fixed and flexible automation. That's what we are focusing on. And now the new one, and we implemented the new course, it's how to integrate systems. Not just like I was in Germany and we visited BMW. And so traditionally, we would see one machine, turning machine, milling machine, some manual machines. Here it's a little bit different. Well, it's a huge difference. You have 5, 6 machines clustered in one big unit, and they work as one unit. This is amazing. That's what how we program and how we automate systems, and they produce gears. So it's kind of a cycle. It goes through turning, maybe then milling, then turning again, you know. And one operator works for those machines, 6, 7 machines, one machine operator. This is amazing. That's how we consider it, how we can put systems together, integrate them. Okay. Very complicated field. Electromechanical, you need a lot of knowledge. Okay, so let's say you graduated, you have 2 options. So you can join industry, and now industry is just trying for graduates. We need graduates, MIT graduates. Our employment rate is getting better and better because industry is picking up. But you have another option. If you think about degree, so I would suggest and advise to plan it in advance because you need a good GPA to be competitive. You need to plan what major you're going to take, and you need to do research which university you want to go. So we do have few very well-established transfer options, and the most successful and the most popular, I would say, and I'm not going to advertise anything, I just from my experience, it's of course University of Calgary. We have a bridge, that bridge was started 7-8 years ago, and it became very popular. From beginning, they kind of, it was so popular that GPA was 4.0 to get there. It was very competitive. And then over years, as kind of, especially during COVID, the GPA a little bit fell down. So now it's 3.6, 3.4, it depends on the year. We never know what GPA will require. I'd like you to know that for that U of C, it's energy engineering. It's not mechanical engineering. It's energy engineering. But it's a good bridge. And by the way, they're coming with info session on February 15, I believe so. And you don't have to like kind of make your decision now, because while you're studying here, those universities will come with those info sessions, and they will give you all details, and you can ask all questions to identify your best option. So the next one, I would say it's Camosun College. Camosun, people pronounce it differently. So it's in BC, British Columbia. So, and we have, that college has just a bridge program. So they accept you. You have to select university, because Camosun College leads to 2 universities, UBIC and UBC. And UBC will include both campuses, Vancouver and that, where is the second one? Sorry. No, BC. No, no. It's a UBC. But anyway, 2 campuses in BC. Yeah, so Vancouver is more expensive. So that's a good bridge. I like it because it's very structured, very good on students. They're not overwhelmed, they're succeeding, I'd like to say. And the structure works like 2 + 2. 2 years at MET, you graduate, you're getting good grades, you can compete with other students. Then the bridge, it's 6-8 months. And then if you're succeeding in that bridge, they will accept you to the 3rd year of university. No credits for different courses, like for single courses, it's just a bucket. MET grad, that's it. Your GPA, transfer option, bridge, and 3rd year of university. The same structure we have for Lakehead University, also very successful. It's a little bit more complicated and tougher on students, but it's a very successful university. They love our MET students. They're working with us how to improve it. So very good university. This is on Ontario side. So we have Montana Tech, and they're coming with info sessions from US as well. We have University of Wyoming, but it's US. If your parents graduated from those universities, I believe they're going to waive you international fees. But how many students we might have? So it's very rare cases. Okay, any questions about transfer options? Okay, yeah.
Somebody wants to know what the biggest difference between this program, so mechanical engineering, and power engineering technology is, because they love to work in the oil and gas industry and can't decide between programs.
So, okay, power engineering, it's a different program. So it's a totally different. So if you graduate from mechanical engineering, you might join the same oil and gas. I worked for Schlumberger, Baker Hughes, Tesco Corporation as a design engineer and manufacturing engineer. And last 6 years before I joined SAIT, I became quality assurance manager for 2 plants. And you're doing mechanical design. So somebody has to design those packers, hangers, liners, to put it in and get oil, right? This is mechanical equipment that allow a company to get oil from down. Power engineering, you will deal with production. It's a different side of the story. So you might work for the same Schlumberger, right? But you will deal with production. So you have to go to those fields. I don't know what they do exactly because I'm not part of that, but yeah, it's a different side of functions. Did I answer that question? Sure.
Somebody wants to know what the transfer option looks like for the University of Alberta.
We don't have any transfer options for University of Alberta. We don't have official transfer options. However, you can come to that university, show your transcript, and ask how many courses might be eligible for credits. It will be single course, single decision. It's tedious, but if you want to go there, I would recommend to contact the department and check maybe what courses might be eligible. They probably have that, maybe statistics. But again, it's going to be more complicated. Yeah, you have to deal with single courses. And I don't think they will accept too many courses for credits. That's my experience, very few. Yeah.
The person wants to know in terms of job opportunities, which one is more likely to get hired? And so thank you so much for answering the first question.
Okay, so first of all, how can I say that? How do you know what is going to happen next year? How we can know that? We don't even know if we are going to be in a recession or will be in booming. It depends. It depends. It depends what you love to do. Like if you love mechanical, if you're mechanically inclined and you like working with software to design things, and then you like to go to the manufacturing facilities and watch how design is going to be built, you know, if it excites you, it's a mechanical engineering. That's what excites me. If you're looking for traveling and dealing with companies and dealing with production, oil things, I don't know what they do. Yeah, that's your choice. However, you never know what employment rate is going to be next year. Like we are living in a very fluid world. Today, like for mechanical engineering technology, our employment rate is was 93 a few years ago, then it slowed down to 76 in recession, like 5-6 years ago. Now it's picking up and it's 90 plus again. And again, it's even within MET program, we have different percentage with different majors, and they're changing every year. Like one year we have 100% for automation graduates, in other years for development graduates, you never know. So it depends. But if I would recommend you, my recommendation, go with what you love to do. Because that's what makes you successful. When you're passionate about something and you're enjoying what you're doing. Any other questions?
Should be the correct one is, can you directly transfer to UBC if you graduate MET from state?
UBC.
University of British Columbia.
Yes, that's exactly what our Camosun Bridge is for. So you can, if you go to Kamosan College website and find transfer options for mechanical, and you will see the long list of many programs, electrical, mechanical, chemical. So find mechanical, and they will show you options for UBC. Again, both campuses, Vancouver and why I cannot remember the province. Anyway, so yes, UBC is on the list, and also UVic. So you don't have to make that decision, but you have to join different time for that transfer option for that bridge, because one is in the winter, one in the summer. Depends if you prefer UVic or UBC. So, but yes, we do have that direct bridge with UBC. Absolutely, yeah. The one of the best in the world, by the way. UBC is a great school. Any other questions?
One more.
Okay.
What if the person doesn't choose the bridge program and directly applies? What are their chances?
Apply
Just to any university, they don't use a bridge program.
again, as we said, as we discussed about Alberta University, it will be the same story. You submit your application to that university you want to go to. Then once you become a student, and I believe all schools have the same rules. So you present what you already completed at diploma level, and you can maybe get some recommendations or maybe you can apply for those courses, and you don't know if you receive or not receive credits. So first of all, it's they on their website, any university have rules what courses are eligible. So then you have to submit your course outlines, they will review it, and they will say, sorry, no credits. Or they will say, yes, it covers 80% of our class, or maybe two courses can be combined and maybe covering some classes. But it's a tedious process, and it costs money, of course. Each course will cost you money to get credits. Yeah. And it's not, you're not getting too many, honestly, like from my experience, very few. Okay. Transfer options. No questions. So I just listed what I'm working with, what I know, and what students experience I know from those schools. So it's, again, I'd like to resume. Kamosan College, Lakehead University, our U of C, yeah, Montana Tech, I got a few students. All right. Well, we already talked about it. So I think it's already, I'm behind a little bit time, right? So just name the sector of industry. It can be oil and gas, it can be manufacturing facilities, it can be, by the way, for automation, warehousing is a huge one. If you ever been in Walmart warehouse, it's fully automated, like you don't see too many people. Wood products would be, of course, development, food processing, automation, technical sales everywhere, all across all majors. Oil and gas, still a big one. It's a big one. We are in Alberta, right? Yeah, technical industry, yeah. Whichever company requires design, they need technologists in mechanical engineering. Even simple design, no matter what, drawings. Okay. Yeah, this is our grad employment rate. This is median. I think it's a little bit higher now, actually. And by the way, this lady, this is a very special lady. Can I, 2 minutes? Just would like to say, Abigail Watt. She graduated mechanical engineering in 2018. She was a participant of, she was nominated for Governor General, my goodness, Governor General medal, and she received bronze. She was a president of that concrete toboggan club I showed you pictures for. And during her presidency, the first time in history, the team won the main trophy. And they were competing with 26 universities. She is a special lady. Now she came back and she's teaching MET this fall, this winter. And she worked for Engineered Air, HVAC. Very special lady. Let's see how she is going to teach as an instructor. Okay, questions? All right. Any questions, guys?
I would like to ask a question. I graduated from mechanical engineering. I have been already for 7 months ago, actually. I've been like.
You mean University of Calgary?
No, actually, I arrived in Calgary before 7 months ago.
Okay.
So I'm interested to continue my education because I have a Bachelor of Science in Mechanical Engineering.
From which country?
From Turkey. Yeah, and I have more than 7 years of experience in my field, technical management or project engineer, I would say, generally. But I would like to continue my education, not like to, because I have a confusion about the colleges here, because, you know, I have a bachelor, so how should I get back or so? That's why I would like to ask that, because I would like to add like to my profession and my diploma as well, not to get back and having had the same textbooks like as I had before. So that's why I would like to get your recommendation.
I'd like to give
I
you,
lost the topic now,
Yeah.
so that's why.
I'd like to give you 2 examples. A few years ago, we got one student from Ukraine. He had master's degree in aviation,
Okay.
and he couldn't find any job related to his field, his background, and he joined mechanical engineering automation major because he wanted to complement his existing education with something that he can apply. Automation
Yes, of course.
was a good one.
Yeah, exactly.
And I think after graduation, he found the job in Montreal, Bombardier. I don't know, Bombardier, it's aviation, right? So that's one example. That was his decision. His education was very relevant and very fresh, like it should be within 5 years, I believe. So we accepted a lot of credits for him, and it took him 1 year to graduate from MIT.
Okay, I mean, do you have any fast track programs for like certification? Because actually I applied for mechanical engineering technologist here, like once I arrived in Calgary, they accepted me, but I checked the course like syllables. It was totally the same that I had before, because for me, I would like to add, not like to see the same topics that I'm.
So we
If
have,
if I see the same topics, it will be like totally lost of time for me.
I understand,
Yeah.
yeah.
So that's why I'm saying is that I would say certificate or certification would be better than diploma, because only that.
So you will maybe hear about entity. That's a short one,
Non-destructive testing. Like, it's kind of an hour.
but it's
Program, but it's not.
engineering.
Yeah, I know that's right. But I would like to go with automation, could be possible.
Yeah, so that's our structure. So if you see
Design
this
process.
line, so this is traditional mechanical engineering course, and most widely used custom.
Yeah,
Fluid mechanics, thermodynamics, heat transfer,
yeah, exactly.
vibration analysis,
Thermodynamics,
all of them, the same
physical
books
theories,
used,
yeah.
even like for the machine design,
Yeah.
our instructors use Orlov Russian book. So it's all like worldwide. It makes sense to use the same resources.
Yeah.
right? For education. So this one is what you completed. I mean, you are higher because you are on the level, right?
Exactly.
But
yeah,
that's
what
what
I'm
you
saying.
found, we are just building foundation. But if you look at automation option and design and development option, it might complement your education and help you to get your local education here, so which is acceptable in Canada.
Yeah, that's I'm trying to understand that because based on that, I can add like my experience
some-
and diploma and the rest of
Yeah.
the automation.
And
stuff
you
on
might be eligible for few credits. You probably don't need all of them, all of those courses, but I cannot make that decision. I cannot advise you because it has to go through RPL department.
Yeah, actually, I gave my own diploma and they checked it out and they accepted me. After 1 week, I got the acceptance, but I was hesitant to start because I just wanted to understand like what's the, I mean, in depth, like could be helpful for me because I don't want to review the same topics, I would say, the textbooks or whatever.
Okay, were you admitted to mechanical engineering at SAIT? And you dropped it?
Macro,
Okay,
because I came to the campus and I met one lady, she was explaining the process and gave her like my diploma or original was the actual one.
I would suggest we can discuss with you your personal situation, because I know that Greg needs to present as well. So we can discuss your situation,
Okay.
okay? Um,
Sorry.
no, don't be sorry. That's why you're here. You have questions and we need to help you.
But it sounds
Will
like
do.
you spent some time to.
Yeah, exactly.
I'll help you. I mean, not help you, but I'll,
Have the email, I have my.
yeah, sure. Okay. Any other questions? Okay.
They're wondering what the advantages in the job market would be if they continued to the university after completing 2 years of META. So if they went on and did the bridge program, what would be the advantages in the job market?
So again, it depends. For instance, we have some companies, let's say, their head offices in Houston or in US, somewhere else, and they just hire technologists only. They don't need engineers because all drawings provided from head office and technologists just doing red line corrections, right? So again, it depends what you want to do in the future, because technology role is support engineers and help engineers to collect information, to do research, to do drawings, to make drawings, and present it to engineers, and they will review and sign and maybe push to productions. And engineers will work on that maybe big assembly level, and the technologists will work on the drawing level, on the single parts level, or maybe small assemblies. A lot of technologists are getting into a great career because they're smart and hands-on. So if we compare university and technology program, I always recommend to go through technology program, get practical experience, because it's really practical. Our equipment is amazing. If you attend open house in February, we'll do provide tours, so you can see our facilities. It's amazing. What students are doing is outstanding. And then with that knowledge, with that practical experience, then join university, because it will make so much more sense to you when you get deeper in theory. If you want to become an engineer, that makes sense. You probably will, some companies, like big companies like Schlumberger, they will watch out for your degree and they need professional engineers, right? So that makes sense. So it depends what really you want. Yeah, and depends on your talents, right? And what kind of, how smart you are, because you can educate with the different levels, right? So yeah, but it's just, yeah, it's a good question actually. think about it and think what you want, where you want to be in a few years. Yeah? Right? Okay.
Well, now,
Next one will be.
No, no,
You're not interested.
yeah, exactly, and I'm not interested in welding.
Sure.
So, AET, which, thank you. No, no. Exactly, yeah, so.
Yeah, get it sorted out. Thanks. So good evening, everyone. So my name is Greg Bull. I'm the academic chair of Welding Engineering Technology and Non-Destructive Testing. So just in simple terms, both those programs deal with inspections. So welding engineering technologists, I would say, are very specifically focused on welding and quality assurance. Non-destructive testing is a smaller program, shorter program that is only 15 weeks. So welding engineering technology is a 2-year diploma and non-destructive testing is 15 weeks. Just very quickly, I think the draw to non-destructive testing, which I'll present last, it requires grade 10 math and it's a 15-week program. So you start in the fall and you're done at Christmas, or you're start in January and you're done in the spring. So non-destructive testing foundations is a very small program, short, gets you to work really quick, just in simple terms. How many of you are interested in either welding engineering technology or non-destructive testing? NDT? Okay, awesome. Anyone else? In both?
I believe welding.
Okay, great. So we've got people that are interested in both, so that's great. So there is some overlap in both of these, and my presentations are a bit shorter, less detailed than Olga's because the programs are smaller. There's not quite as much detail to go through here. So I'll just give you kind of the overview of what the courses are about. So this is Welding Engineering Technology. Again, just told you my name here. My name is Greg Wall, academic chair. Very quick background about myself. I taught in the mechanical engineering technology program for 15 years and just recently took this new role in these programs. So it's been really interesting for me because I'm learning a lot about these new technology programs, and it's a lot of this is within mechanical engineering technology as well. It all overlaps, so it's pretty interesting. So anyway, the program overview on welding engineering technology. It's a 2-year hands-on education. First year focuses on academic fundamentals, structural steel design and fabrication. And the thing that I think really stands out about this program that's quite different than MET is that the students in this program do a ton of welding. I go down to the shop every morning. I see the students there. There's grinders, there's sparks flying. They're welding pipe, they're cutting pipe, they're fabricating different shapes, reading drawings. We have a plasma cutter down there, a robotic welder. So they're learning all the different sort of technologies in welding. The thing that's important to know about this program, though, is if you're interested in being a welder, so somebody that would be like an apprenticeship welder, this is not the program for you. So we like to make that clear. If you're interested in welding, the welding apprenticeship program or the welding and fabrication technology programs are for you. This is more in kind of the management or the testing of welding. So you would likely, as a career in this program, you'll be working with welders, but doing inspections of the welds that are there. So you'll know welding inside out because you do it for 2 years almost every day. And you'll know all different types of welds, all different types of processes, and you'll be able to do the testing on it. So that's kind of the difference there. So it's a really interesting program. It's been around for 50 years. So I was in my first year becoming the academic chair. It's kind of an interesting time to start because we were celebrating 50 years in this program. So it was really interesting to see some of these people who were graduates of welding engineering technology in 1972 three and in the 80s attended this event. So some people in this picture were here, but obviously a little bit older and let you see them here. But it's been around for a while and it's a very successful program. We have a 100% employment rate, which is quite rare at SAIT. I've seen a lot of programs. I noticed Olga's is in the 80s, which is generally quite normal at SAIT, but because this is so connected to the oil and gas industry, welding pipelines, testing in that industry, pretty easy to find a job. So that's a strength of this program for sure. So this is just a quick overview, and I won't go into too much detail, but these are the courses that you would take in the program. So in your first year, when you come to SAIT, you'll start with a blueprint reading course. You're going to learn how to see and understand and read drawings, how to read a blueprint drawing, some computer fundamentals. This course is something you take in any technologist program, but the fundamentals, Word, PowerPoint, Excel, just the basics in computer fundamentals. Engineering materials, so it's a lot of study in how materials work. So there's a couple of materials courses here, a math course for technologists, some physics, and these are the courses here, the hands-on welding courses, WDSG 235. That's the course I said that I go down in the shop and they're welding coupons, they're learning to weld, cut. There. We have a communications program, some presentation skills, writing skills. So you learn to become a better communicator. One of the skills as a technologist in any of these programs is that we teach students how to communicate technically through writing, drawing. Second materials course, more math, project management. So it's a whole course in managing projects. Again, big part of welding engineering technology. Some statistics. Anyone that's taken any post-secondary statistics is always a tough course, but it's there. Another hands-on course here in the shop, weld and inspection practices too. That's your first year. And then your second year, we go to a course called Codes and Regulations. So a whole course dedicated to codes and regulations in the welding engineering technology area. Metallurgy course, that one's really interesting, where they do a lot of, I guess, destructive testing to metal parts and welds, and then they put them under a microscope and review how that performs. That's pretty interesting. There's one course for the NDT guy here in non-destructive testing. So this is where they overlap. So the students in welding engineering technology get a very quick overview of the 5 methods in non-destructive testing. They likely won't do it, but they just get a sense of what it's about. Statistics, and then we get into some welding again, second year weld and design practice course, mechanics of material, failure mitigation, and then your capstone, which is called research and design solutions. Interesting course where the students will do a bunch of welds. They take them actually down to the NDT area. They get them x-rayed. They have a review their welds, look for any defects, sometimes review them, and then they cut that sheet of material into a bunch of tests that they do tensile testing on their welds to make sure that they are good, strong, robust welds. So that's their capstone project. Another one, this one's really interesting. This is the one I'm excited about. All of these technology courses end up in robotics. So this is our robotic welding course, automated manufacturing. We just got a new machine called a cobot that does welding of pipe. Very simply, you can take the arm and so it give program points, but it kind of learns from what you tell it. I want you to weld from here to here to here to here. A few inputs you put into the computer, you hit go, and this thing will just weld a perfect seam around a pipe, which is really interesting. And the weld is perfect. It looks like a washer. No pools in it. It's just really interesting. So anyway, I'm really excited about that one because we've got that machine and the students are very excited to try it out. So that's an interesting course. Another course in weld and design practices will be your 4th lab course, and then a final course in CAD. So all these technology programs, you learn to use a CAD. We had some students in the lab today that were using CAD lines with our plasma cutter and laser cutter to cut out plate steel so they could weld it, so you could draw it in a computer and then make those parts. So that's essentially what the entire program looks like in a quick overview. Just some other information here about the program. It has like I said, many practical welding labs, as well as one of the highest course loads at SAIT. The students in welding engineering technology are very, very busy, but doing fun stuff. They love being in that lab. When I'm down there, they're just like fully engaged, really into it, but it is a lot of work. So students expect 40 to 50-hour work weeks. As a specialized program, a strong interest in welding is important. Prior welding experience is not required, but you will start at the beginning and we'll take you through the whole process, and you'll learn mostly any welding process that exists. We cover it in welding engineering technology. So admission requirements, at least 50% in math 30 or 31, pure math 30, or at least 70% in 30-2. And at least 50% in language arts 30-1 or language arts 30-2, and 50% in Chem 20 or science 30. So a little bit less requirements than MET. All applicants have to demonstrate English language proficiency prior to admission. Okay, so I'll just keep going here. I'll go right through and I'll answer questions at the end if that's okay for everyone. I don't hear any questions yet, so I'll just keep going. So the areas of study here, as I kind of covered with all those courses: materials and metallurgy, codes and standards, welding, economics, automated welding. So I mentioned the cobot there. If we touch on non-destructive testing, they get to interact with some of those methods. They get to see what that looks like. Failure mitigation and applied research. That's in a nutshell what the program's about. Connections to industry. So when you're here, most of our programs at SAIT, I would say all of our programs at SAIT, we try to connect with industry regularly. So in welding engineering technology, we have a student club called the Welding Engineering Technology Student Club. They get together a lot to talk about welding and the courses. They'll put together nights with people from industry to come in and do presentations of what they're doing for work. We have industry nights. We have a CWB Calgary chapter technical dinners. We have a student paper contest, the IPEA conference, which is coming up at the end of February. One of our students was just recently selected for that conference and will be presenting a poster there. So they get to go to Jasper and present to all the people in the pressure industry. And then we have another seminar course that's free to all students. It's an entire Saturday in February that is free to students. A bunch of industry professionals come in and talk about the pressure industry and welding technology for students. So we have a number of good connections to industry, which also helps us with getting students jobs. So welding engineering technology is the only 2-year nationally accredited program in Canada. It's also recognized as an international welding technologist authorized training body. WET graduates are recognized in 55 countries across the world. So it is possible to get jobs internationally with our program. Like I said, 100% employment rate. I think, like Olga said, these numbers might be a bit old, but still the starting median salary, median in the middle, 68,000 to start. That's pretty good with a 2-year diploma to start. It's probably a little bit higher than that in the current economy we have now, but that's from 2022. So most of those jobs are in inspection, asset integrity, manufacturing, structural fabrication, non-destructive testing, or other areas. So some of our grads do go into non-destructive testing, but not as much as the students who take the foundations program. So career opportunities, I think I covered this, but welding engineering technologist, welding specialists, inspectors, corrosion inspectors, welding automation specialists. Related careers include mechanical and engineering technologists. So like I said, there is a lot of overlap between what Olga just said and what we're doing, but we're really specialized in the welding and steel areas. Some students, not many, will end up being welders, although they won't be apprentice welders or journey people. So that's important to just note. Non-destructive testing technicians or materials engineer. So yeah, just a very quick, hopefully this video will work online for everyone that's online here. Let's hope it does. Find my mouse here. Where is it? Okay, I need to use the, oh, there we go. Thank you. Just like trying to find it there somewhere. Again, sorry. Link's working very well here. Sorry about that. For some reason we have a broken link on this presentation here. Is there any, I don't know how we could do that. I think this link, hang on. Great. And then while she's doing that, if you don't mind, I'll open it to questions. If anyone has any questions on the program, and I can show the video in a second. Any questions? Any questions online here? No. Okay, thank you. So no questions? So either there's no questions or I did such an incredible job of presenting that I've answered all questions. Let's go with that. We'll go with number 2. To see if we can get this link to work. I think it's about a 2 or 3 minute video.
So we do have one question from online asking what opportunities are there for further education in the web program?
Okay, so that's a good question. So unlike MET, we don't have any formal agreements for students to go bridge into other programs. But I think similar to the question about the University of Alberta, you could, oh, fantastic, thank you. You could apply to other places and get some credit, but we don't have as much, we don't have a direct link like Olga's program does to university programs. Okay, I'll let this video play and then I'll catch the next question in a minute. Okay, everyone online see that video? Great, thank you. Okay. So it's just kind of an overview of the area that you'd study in. So if you, this is in our lab here. So this is the lab I was telling you about where the students are doing a lot of welding. This is some of our welding booths, some of our mechanized welder equipment there. This up here, it's a bit dark, but you can see some, this is usually what you see when you go in the lab. Sparks flying, welding happening, grinding. This is literally the live classroom, is what I see every day when I go out and talk to instructors. Those are our welding booths. We have 16 welding booths. This is this is our old robot. This is one from 2000. It's the Panasonic. It's a lot bigger and clunkier than the co-op, but it's still pretty interesting. The students learn how to program that to do paths for welding. And some other examples of in-class activities here in welding engineering. That's our plasma cutter in the back. This is where students take their AutoCAD lines and apply them to the machine. The machine will cut out parts that are drawn in AutoCAD on steel. This is inside one of our welding booths. Every welding booth has acetylene, oxygen, and wire-fed welders in them. We have 12 fabrication tables like this for all the student projects. This is a good example of one of the projects where students just weld plate together. Weld. See, people online will just have to imagine all these things I'm talking about. When you see the video, you'll see what I'm talking about. So this is the metallurgy lab I mentioned. This is the tensile tester. They put pieces of steel in there and they pull them to failure. That's a lot of fun to watch. Makes a big gunshot sound when it breaks. Have you seen those? Yes, I'm sure you did that in your degree, right? There's a graph that shows it on a screen as it goes. You know exactly what it says. You probably, I think most of these courses are the same in yeah. And in fact, this same course is in mechanical engineering technology. This course. Yeah. Just about at the end. So again, this is our metallurgy lab. You'll see the scales. We have a bunch of sanders and microscopes, testing equipment to review the properties of the metal material. This looks like one of our instructors, Stephen Kenny. Very good instructor, wins many awards. The students quite like his classes. So anyway, that's welding engineering technology. Was there one more question online there that I can?
They were just looking for information on non-destructive technology, which we will be presenting on right now.
Thank you. All right, so that was welding engineering technology. Next program is non-destructive testing foundation. So this one's much shorter. So like I said, the last one was 2 years. This one is a 15-week program. The advantage of this one, you're in and you're out in 15 weeks. A bit more expensive, but you're in and out in 15 weeks. So a semester of this course, I have to look it up again. I want to say it's 10,500, if I remember correctly, for the entire program, which is a bit more than a traditional semester, but you're in and out in 15 weeks. So I'll go through this. So non-destructive testing is designed to enable you to enter the growing non-destructive field by providing a foundational knowledge of the 5 NDT methods in the inspection industry. So like I said, I came from the mechanical engineering technology program. I find this program fascinating because it's the place where we end in design and engineering. We design things, they go into the built environment, and then you always wonder, how long will that last? Will it fail? Things like bridges, telephone poles, jet engine turbines, all those mechanical things that are in the built environment, we need to regularly inspect them and test them to ensure they're not going to fail when we're using them. So one of the things that I learned very quickly here that I liked, I don't like flying very much. I'm a mechanical brain, so I'm always in the plane thinking of all the things that could go wrong. But when I found out that non-destructive testing is employed on these aircrafts, when they're down, when they have downtime, they go through all those parts, they take them out, they scan them, they inspect them for any defects. If there's defects, they get replaced. So non-destructive testing is a very quiet industry, but a very busy one. There are tons of jobs. I've seen a couple of really interesting presentations recently. One from a company called Sperry Rail. It's basically a job where you're on the train rail and this car goes around, you're inspecting train rail across Canada. Sounded like a great job. You're traveling around Canada on this car. They're testing rail. So that was an interesting one. The other one that was I found out that I didn't think about where non-destructive testing is applied was Callaway Park has a number of non-destructive testing professionals that come in the winter. They decommission all the rides, take all the parts apart and NDT all of them. So they check all the rivets, all the beams, all the structures, check for any defects, and then they reassemble them again. So that was interesting to me. Those are just two examples, but NDT is anything in the built environment could be NDT'd. So essentially what it is, and I kind of skipped ahead here, but it's identifying mechanical and structural failures to save money, time, and lives. So in a big way, like, this is a very important industry from the point that it saves lives. If we can detect a defect in a part before it fails, that's pretty important. So that's our job in non-destructive testing. There are 5 methods, one of which is called eddy current testing. So this is where electromagnetic testing makes use of induction to detect and characterize surface and subsurface flaws in conductive materials. So it's, that's a simple way of putting it, but it's really interesting to see they'll charge a part magnetically, have these small particles that find their way into the defects, and you can see them in all the cracks. It's really interesting. Another of the 5 is radiographic testing. So in other words, X-rays, so gamma rays examine the internal structure of manufactured components, identifying any flaws or defects. So in some ways, these 2 methods especially are not unlike what happens when you go to the doctor and they're checking your organs. We use X-ray or radiography to check, see what's going on in your body. We also use ultrasonic testing in the medical industry, and it's used in industry as well. So ultrasonics uses sound waves to detect cracks and defects. If I had to pick a method, because I'm kind of an audiophile and I really like music and sound, ultrasonics is interesting to me because they use sound waves to do the testing. So you can detect the thickness of a pipe using sound, and there's an interesting meter that you can use to do that. So those are 3 of the methods. Another interesting one is called liquid penetrant. So essentially you're applying a dye to a surface or an area. So in this case, they've in the top right here, they've applied it to a weld. And what the red will do is sink into the defects, clean that away, and the penetrant goes into the defects. You can see them better. So it's a very simple way of detecting defects. The 5th method is magnetic particle testing. This is used using magnetic particles to detect flaws as well. In some cases, they'll put it in the fluorescent light and you can see here. What's really cool about the NDT program, when I go down there, I enjoy seeing the students, their exams are parts. So you'll have a student might have a turbine in front of them. The other student might have a beam in front of them. And their test is to detect the defects in that part. So it's pretty interesting. The instructors know what the defects are, but the students don't. So they have to use these methods to find the answer that the instructors already know, which is kind of interesting. So it's very hands-on, very practical, and in my mind, a really interesting program. So NDT certifications, there's kind of 3 steps to this. You complete your training here at SAIT, which is 15 weeks. So we're a recognized training organization. You learn about all 5 of these methods. So all 5 of those you will learn and get your training here at SAIT. Then from there, you have to get work experience. It's generally, depending on the methods, it's between 8 to 18 months work experience. Once you've obtained that, then you come back to us with your training and your work experience, and then you'll take a government exam, which will make you a certified technician in. You can do all 5 of the methods, but generally people will pick 1 or 2. So a lot of our instructors here have 1 or 2 each. We have a specialist in radiography, one that does radiography and ultrasound. So they generally have 1 or 2 methods that they really specialize in.
Which are those, which methods would be most prevalent in the industry?
That's a good question. It seems like ultrasonic is a big one. Eddy current I hear a lot about. And it seems like liquid penetrant is also one that's used quite often. It really depends on the industry. Radiography is an interesting one too. Like it's much more accurate, I would say, but it's one that you have to sort of clear the room. You can't do radiography when people are around. So a lot of these things are done after hours on night shifts when everyone's home. They'll do that testing. So. Yes, I have a link at the end that will tell you exactly what those are. Some of them are different, so I haven't quite memorized all those yet. But somewhere in there, yes, depending on the level that you want to get to. And so from there, once you've come back, taking your exam, the exam here is similar to what I just described. We have a technician here who runs the exam. So you come back. It's a government exam, so the government has those parts that I described. So you'll come in, you'll get a part, you'll be put in a lab on your own. You do the testing, you capture the results, and then your exam goes straight to the government. We seal it in an envelope, goes straight to the government. They grade it, and the results come back to us. So it's very, very regulated. Yes, that's it. Yeah. So.
I feel told by people in the industry that it's several $1,000 to take the exam, and also that it has verified there.
I'm not sure about the costing and the failure rate. I'm not sure it's as high as someone's told you. I haven't heard that. Most of the people, yeah. 90% failure. It's not that high. Definitely, I would reverse it probably. Yeah, 9% get it. I would. Again, as long as you have the experience and you've done it, you know what you're doing. We also offer for people that are coming in to do an exam, sort of pre-exam sessions. So some of our instructors will come in on a Saturday, and if maybe you haven't used eddy current since you were at SAIT and you can come in and do a review session, spend some time with the equipment, do some testing on some of our equipment here to get familiar, and then come and do the exam. So it's not as bad as whoever told you it's so bad, it's not that bad. For sure. Okay, so that's kind of the certification for NDT. Very quickly, this is the course outline. Again, it's a 15-week, it's basically 1 semester. So not as many courses. First one is called Code 270, Materials and Processes. Then we have a communications course, a little bit of writing and technical communication. These are your 5 methods here. So we've got visual inspection, eddy current, radiography, certified exposure device operator, which is the part of radiography, ultrasonics, magnetic particle, and then liquid penetrant levels 1 and 2. And then you're done. So 15 weeks. So students that do well in this program generally are people who have a really great attention to detail. I would say an attention to visual detail. If you're a visual person, this is a very good fit for you. And if you're a very hands-on type person, also a very good fit. There are some applied math skills, but it's certainly not the level of math that welding engineering technology or that mechanical engineering technology would have. And also people that do well in NDT have an ability to follow written and verbal directions and complete accurate reports. So if you like following rules, codes, regulations, and that's something that works well for you, it's a really good fit. It's really what it's about. So work environment students must have successfully completed grade 10 math, grade 10 English or equivalent. So those are the entry requirements. So that's one of the things that I think is a strong entry point for this is it's a good start for anybody. If you don't have maybe the grade 12 math, or if you're like me, you didn't do as well in math in high school and you're looking for an entry point, this is a great place for it. Quick side note, before I went to college, if there's anyone online here that's like me, I had low grades in a few of my courses and I had to upgrade when I was early 20s, but it is possible. So if any of you here or someone online is like thinking, geez, I'd really like to go to mechanical engineering technology or any of these programs, I don't have the requirements, it is easy to find an opportunity to upgrade. We have those at the state, and there are a number of them around. That's not that hard to do. I've done it. Yeah, do you have anything you could verify your math, your high school, anything? Okay. Okay, I'm sure if they would just need some verification of that. But what you usually- Okay. Okay, I think you'd probably want to talk to, would you say student services, Olga, to assess like prior, what do they call that, prior education to figure out your math level. PL here at SAIT, right? We can connect after. I'll find that for you. Sure, and I'll give you my card as well, so we'll find a way to get you connected and find that for you for sure. Right, so all applicants English language proficiency. So connections to industry, as mentioned, lunch presentations. I've enjoyed this being new to the program, just kind of hearing about places like Sperry Rail, Calgary Park, another company called Mistress that was doing drone NDT that they're getting into, which I thought was super interesting. They're taking these drones and they're flying them up to like turbine blades and doing ultrasonics on those with drones. That sounds really interesting to me. So there's a lot of new technologies being employed with NDT. Pretty interesting. We have career hubs. We also are connected with the IPEA event, the International Pressure Equipment Conference. And the same course that's offered in February is offered to NDT students as well. So this is the only full-time program devoted to NDT Canada. Students are provided extra training and time and are exposed to all 5 NDT methods. All of our instructors are certified non-destructive technicians as well. We have a 75% employment rate, higher median starting salary. I saw an article from a few years ago that said that NDT was the hidden $100,000 salary career. It's kind of interesting. If you Google that, you can find it. But it's a very quiet industry that there's a lot of work, but for some reason it's very quiet. I didn't hear a lot about it until I came, and I'm finding it really interesting. I think the reason it's not as noted as others is that it's often after hours, like I said. So people that are in are doing it evenings. You're not seeing the testing because it's done in closed doors or after hours, which makes it really interesting to me. So a lot of it is in oil and gas, aerospace, structural, nuclear powered. I mentioned rail and any other structural company. They're all doing NDT to make sure everything's safe and we're not seeing any failures. Career opportunities. So a similar thing, non-destructive technician, an NDT maintenance technician, inspection technician, physical science technician or technologists, related careers in boiler making, avionics, aircraft structure technicians. So there's a lot of NDT happening in aircraft. I just saw an interesting job posting at Cold Lake for an NDT technician on the CF-18s. I don't know if that's not interesting. I don't know what is, because anything to do with, I'd like to just go and see CF-18s, but it would be interesting to take the parts out of them and do the testing. That would be a pretty fascinating job. Definitely, yes, for sure. They would be NDTing those all the time. There's one of our instructors, George Gavalis. He's been around for quite some time. He was in the Canadian military, and they flew him around the country testing all kinds of structures in the military. All of them. They're always testing the thing. Definitely. Yeah, definitely. So this is that link I was talking about, and I'm not sure how well this will go. I have a feeling that. So I won't spend too much time on this, but just the work experience question for you. There it is there. So these are the methods. So your level 1, 3 months, level 2, 9 months. So let's see. Yeah. And so again, just to review, you would take your courses here at SAIT. Let's say you took it in 3. You've got 3 months experience. Come back to SAIT, you do an exam, CGSB exam, and then if you pass, you become a certified level 1. Yeah, it's a great career for sure. And that's all available there on, can't really see that. Zoom out a little bit. On NRCan's website. I keep trying this mouse, it's not working well for me. So Government of Canada, and it's NRCan if you're interested, Natural Resources Canada, non-destructive testing. Okay, and I'll just give you a virtual tour here. Another short video. So this is just a short video of our facilities down in the Johnson Cobb building, and the link worked this time. So, maybe it didn't. I'm glad you're here. Sure, sure. Great, thank you. So these are some of our testing labs here. This is campus, so non-destructive testing is in the basement of this building here. Off the Cobb building. That's actually a welding engineering technology student project that you can see they applied liquid penetrant to for some inspection. So the radiography facility. There's our X-ray. It's the photo lab to process the X-ray images. Students sometimes X-ray their phones and things like that as well. So they get an opportunity to sort of experiment a little bit. So this is the magnetic particle method. So that's an example of one of their test parts that you would be testing in class. See that defect in it, that line. Okay, I think that is the end of our video. Looks like it. Still want to use that mouse.
Right here, we should be able to bring it back. We're gonna shut this down so it stops playing. Perfect.
Great, thank you. All right, some more information on sate.ca. You can just Google non-destructive testing foundations. Get an overview of the program there. If you want more information. That takes us to questions. So any questions about non-destructive testing?
Somebody's wondering if an NDT technician trained and licensed in Alberta can work anywhere in Canada, or do they need to be licensed in the province they want to work in?
Anywhere in Canada, because we're regulated by CGSB or NRCan, so it's a Canadian-wide regulation. Should be looking over here. Anywhere in Canada, yes.
Perfect. And somebody else is wondering how large the class sizes are and if this program is in such high demand that it regularly experiences waitlists.
That's a good question. So the class sizes are 30. So there are 30 people in every 15-week session, and they don't always overfill. This last semester we're a bit short, so I think we have 23 students in our program this semester we're in now. The last one was 30, so there's no wait list at the moment.
All the questions we have online.
Okay. Any other questions about any of the other programs as well? I'm happy to. Back to Olga, welding, engineering, technology, or. Yes. Does that appeal to you?
Yeah.
NDT seems like it's often off-site like that. That Sperry Rail project was one that I sounded like was always away. Then you're home for a while and then you're away. There were 2 students in the back that I could see that appealed to. They're like, when do we apply? I want to go now. They were pretty excited about that idea. There are also local ones as well. Like there are companies in Calgary that do just local work, but often they're off-site. That's a lot of traveling. Yeah.
So maybe the Canadian trained tech can work throughout the world with their Canadian service.
That's a good question. I might have to get back to that person on that one. I know that the CGSB regulations come directly from an international one, but I don't know for sure the answer to that. So if you could give them my email, greg.ball@sate.ca, I'll find the answer. I can email them back. Or next 4 days. Okay, thank you. Any questions here? I'll let you write down my email as well, which is greg.ball@sate.ca. And if you have a question you think of tomorrow or next week, you can always email me. I'll let you know. Also, if you're interested, sounds like you might be. If you wanted to see the labs, you could always drop by. I'm down there often, so come in and I could give you a quick. Sometimes helpful just to see it and see if it feels like the right place for you. I get the feeling it is, but I just want to see it for sure. Oh, interesting. You're familiar with NDT, you know exactly what it is then.
Well, yeah, I was at your last session here.
Excellent. We'll help you do that for sure. Go ahead, Olga. Sure.
That's a good point regarding visiting our nurse. We do have an option for you, it's not a student or day.
Mhm.
Just send us a request. If it's info
you guys know, so you don't have to worry about.
Great.
Yeah, just go off the online session.
Okay, I see. So if you would like to come to see, you can join our office for 1 week. I don't know if you have this program immediately, but we will do that. If you want to see what it is inside, what kind of construction here, what facilities you need. And we will.
I was trying to remember, it was M&A info or info at M&A.
So, I think, yeah.
Excellent, thank you.
Okay.